broadcasting secretly from where you don't need to know. So curse you scallywag, you'll never take away my pirate radio.
Hello and welcome to Pirate Radio, where we are doing a podcast with terrible video and we talk about all things pepperoni. Thank you very much to Piratesaurus for the theme tune, and without further ado, we have our crew. Hey Chris,
hello.
Hey Phil.
Hello.
I can hear you, I can see you.
Excellent.
And today we are going to be talking about the Raspberry Pi Pico and where we are with software and just the general software ecosystem in general. So hi, and let's start with what is a Pico?
What is a Pico? Don't ask me. So the Raspberry Pi Pico is it's a custom microcontroller. It's their own silicon. They've basically taken the idea of a beginner microcontroller and thought, how can we make this better? How can we do all the things we've always wanted to do in silicon and release it at an affordable price to the wider world? And they appear, to all accounts, to have knocked it out of the park, so to speak, apart from the lack of a reset button, which we do have a fix for. But yeah, the Pico is, I guess, the Arduino, the 80 mega 328p of the 2020s. So we've kind of come full circle back around to that, encouraging people to develop on microcontrollers and to build applications that start instantly, that are simple and easy to reason about within reason, and quite fun. So yeah, what else can I say, really?
I think so. We'll cover really what the approaches are. What are the ways you can approach programming this microcontroller from the super pro end to the kind of super potato intro end?
I would contest that programming C++ on the Pico has been made approachable enough that it's no longer super pro, but that the PIOs, the kind of jewel in the crown of Pico, is their programmable. Programmable input and output controllers, basically. They're kind of a tiny, very, very basic state machine that hangs off the back of the Pico and will take a few instructions and do some clever stuff. So that's always there as the lowest apple on the tree for the incredibly technical people to get some fun out of the Pico and really push it to its limits. And people have with, I think there's a network interface now that is running. There's HDMI, there's VGA output, there's I2C and SPI running over the PIOs, which means you can put digital buses on any pins, and that gives you like really advanced stuff. The C++ stuff, the tutorials and guides and the introductions, the SDK, it kind of falls somewhere between lofty, high, and difficult C++ and easy sort of Arduino C++, and strikes this middle ground, whereupon it's at least somewhat approachable for a beginner to kind of dive in and start making stuff happen on the Pico, do your embedded LOLs and stuff. And yeah, it works. But then you've also got
Python side. What's
Python.
going on there?
We have Micropython and we have Circuitpython. These two things exist for similar but different reasons. So Micropython is like your advanced track, very comprehensive support for a whole array of microcontrollers, right down to the very, very bare essentials, where you're almost just barely getting Python to run on a microcontroller, all the way up to like the STM32s of the world. Whereas CircuitPython takes Micropython and says, we're putting the minimum specs here, and then everything is built on top of that. So that creates kind of a baseline of expectations for Micropython and creates an ecosystem on top of that, which means CircuitPython is a bit more beginner friendly, a bit more kind of educationally orientated, and MicroPython is what you'd use if you wanted something simple, quick to get off the ground. You understand Python reasonably well, and maybe you want to write some firmware for something. For example, if we were writing some firmware for this, perhaps we would grab Micropython, we'd make our own customizations to it, and we would allow people to download and use that firmware straight off the bat. Whereas with
that's the
Circuitpython,
Kibo there.
That is the Kibo,
and that's going to use mainly USB HID and USB CDC or USB MIDI, all of those kind of interface things. And
Indeed,
that's a good leaping off point for what kind of problems are we going to see between using, say, Micropython and CircuitPython.
For us as developers, it means we have many different ecosystems to support suddenly, because we've got Pico C++, we've got Pico's Micropython, we've got Pico's CircuitPython, and then we've got various interactions between those. And then there's the Arduino IDE will no doubt be, or Arduino HAL, I should say, will no doubt be ported to Pico in such a way that we'll need to support that as well. But hopefully our C++ libraries will have that covered. We'll see. So
right.
Yeah, it's a complicated world in which CircuitPython already has very comprehensive drivers for many sensors out there, because it's been something that Adafruit have been backing for a while now, and they have like a very strong organizational structure, lots of contributors, lots of contributed drivers, lots of first-party drivers, and a very large and thriving kind of community around that. That means that for the most part, we can take something like Breakout Garden, which I think is another thing in the works, and about 90% of our modules will work already, give or take, with CircuitPython, because they're just relatively standard sensors that everyone has a breakout for at this point, including Adafruit, of course.
Micropython, Chris, that's where you come in.
Yes, yeah. So the approach we've gone for is to, being as though we wanted to support C++ out of it, or anyway, we're going with the approach of wrapping C++ or wrapping around to give the Micropython, rather than necessarily writing drivers fresh in Micropython. Now that gives us, on the developer side, the advantage that we don't have to write drivers twice, but also lets us get some extra performance that you perhaps wouldn't otherwise get, and support things like the Unicorn pack, which uses the PIO. That's relatively easy to do in the C++, but a bit fiddly to do in Micropython. So we bypass that by doing it at the lower level. And then we expose functions that we think are convenient for the particular product. But it does mean we have to write bindings for everything.
Yeah. So as an overarching thing of what we're doing at Pemberoni, traditionally we've been largely a Raspberry Pi and Python house with very little embedded. That's about right, isn't it, Phil?
It is, yeah. It's a matter of fact.
And so this is a bit of a step change for us. But our approach is, we started off kind of looking at Micropython since it was officially supported and officially ported by Pi. And CircuitPython is ostensibly a branch of that, but it's more complicated than that. And we found ourselves supporting all of these things. And I think we've kind of gone down each trouser leg a bit and gone off trying to do native Micropython before coming back to this thing where we write those C++ drivers and then shim them with Micropython and provide a, what did you call it? What did you call our Micropython build?
I call it a batteries included Micropython build. So it's basically a custom build of Micropython that just has all of our C modules compiled into it. And that's a contentious thing, because people will expect that if every manufacturer then does their own custom build of Micropython with their C modules in it, there's no way to combine those things together. And that may be the case kind of for the time being, but currently no one else is doing that, because we're championing the whole method of being able to do it at all on the Pico. And if people do it in future, then it's still relatively straightforward. And in fact, I have some long-term ideas for making it easier to roll the version of Micropython that includes the C drivers that you want. You should just be able to collate them together, compile your own version, and away you go. Which sounds complicated. It isn't, and it can be a lot easier than it even is currently, which will be interesting.
Which is where CircuitPython shines at the moment, isn't it?
It is. Well, CircuitPython basically doesn't do any custom builds, doesn't do any kind of compiled in libraries in the same way that MicroPython can, and we are with MicroPython. With CircuitPython, you'd be able to write a driver and upstream it to their platform, and they'll include it, and it'd be everywhere, basically.
And you can drag and drop you as a user can drag and drop the modules you want onto your CircuitPython device, right?
In
which
Python
is
rather
great.
than C.
Yeah,
and
because the custom builds. Go on, Chris.
I was going to say, because CircuitPython appears as a flash drive, so the Pico appears as one to let you put a UF2 on to flash it, but beyond that, if you're using MicroPython, you have to use Thonny or another editor in order to access its internal memory to put your code on, whereas CircuitPython just appears as a mass storage drive that you can put in your code, libraries, files, like images, just directly on there, and then easily write a few lines to reference those.
Yeah, that's one of the things I like about it as a platform, just being able to chuck libraries at it, or in fact the live code reload where you basically just hit Control-D in the REPL and say, now every time I save my code to that target disk, it'll automatically reload it and run it and tell me what's gone wrong. So you can just watch the output, edit your code, save it, see what broke. And that's
so we'll come back to CircuitPython in a bit, but MicroPython, explain a bit more about what you've been doing with things like Ulab.
Now that was something that a lot of people were talking about right from the get-go. With even before the official launch of Pico, a lot of people were interested in getting Ulab running, and it is, as far as I understand, a cut-down version of SciPy and NumPy and some other like accelerated C functions that are all collaborated together into a single C library that allows you to accelerate math stuff, basically. I've heard of people doing stuff like Mandelbrot sets in it, and it would be the sort of thing you might use for preparing and manipulating a screen buffer if you're doing drawing operations, and it has all sorts of other benefits. So as part of our process of upstreaming and reaching out to the developers of stuff, or developers of MicroPython and Ulab and other modules, we now have support in Ulab for it being compiled into RP2 port of MicroPython, and pending support in MicroPython for RP2 or RP2040 to support compiling in C modules. And this pending support is all stuff that we're using presently as because we maintaining those changes. We're keeping a GitHub repository that has them in, and we then use that code to build our MicroPython. It's all a little hairy at the moment. Hopefully, once everything goes upstream and all of these changes are accepted, we'll have a world in which anybody will be able to compile Ulab into their own version of MicroPython. But with stuff like that, with our batteries included approach, we're listening to what people want as part of their setup and including it within our port, I guess, would be the
But at some point we're going to bloat too much, aren't we, and blow out the memory?
Yeah, there is a limit. We're currently at 700K with a very heavy build of Ulab. I think CircuitPython is just over 1 megabyte, if I remember correctly. It might be just under. So we've got some room to grow yet, but it is not a feasible approach in the long term. And that kind of harks back to what I was hinting at earlier. I feel like there's a solution to this problem where we can do a choose your own adventure build of MicroPython, where you just say, I want this library, this library, this library, click go, build it for me, and then give me a download link. And I feel like that is an interesting idea that I haven't had time to fully explore, but we'll see.
So progress MicroPython and C++, where are we right now in which of our modules we support and kind of the roadmap for how many
we have an internal roadmap that I don't see any reason why people can't see. It's basically a ranked list of stuff we need to write support to, or support for even. With who's got what module and allocated lists. So I'm going to switch us over to that. Hold on. Let me see if I can remember my key doobly what's it. So this is the document that me and Chris have been working from internally.
Wow.
Which is basically just
that looks amazingly pixelated for me.
Yeah, same on my end, to be honest.
That's really odd. I wonder why. Compression, maybe?
Yeah, we'll link it later anyway, so people can take a look at things and possibly even put it up as a GitHub.
Yeah, this is something I've been wanting to do, actually, and I had this for CircuitPython and Breakout Garden at some point, where I had a list of all the modules that we provide, all of the breakouts that we create, and whether or not they have a CircuitPython driver available, and if not, some references for how one might start being writing or whatever. This is the same thing for Pico. It's basically a list of all the modules all the breakouts that we produce, who's got it, what bus it uses, whether it's I2C or SPI, whether or not me or Chris have got one, whether or not it's on fire. Unfortunately, if it is genuinely pixelated, nobody will be able to get that. But who's currently working on it, what's currently happening, and it's generally a workflow of either me or Chris will write a initial C driver for one of these breakouts. That will then go to Chris to have the Python bindings written, which will make that C driver available in Python, and then that will be tested and eventually included in our batteries included build. So, where am I? Oh no, everything's gone horribly wrong. Pressing the wrong keys, that's why. Here I am. So yeah, once everything's written and included in the build, then that becomes a functional Python module effectively, except that it's written in C with bindings that glue it to the Python way of doing things. But additionally, because we want to support the Pico SDK, we want to support people writing C++ as kind of not as an afterthought, as like a first party thing. That means that by going through these various steps, we've always got a driver that supports people writing in C, allows people to link it into their project, their Pico SDK projects, and then that will be almost one-for-one in functionality with the Python driver as well, which works out really well. But this is our roadmap. This is where we are.
This is the C++ stuff. This chip is going to enter the mainstream. It's going to be used in all kinds of consumer devices down the line. At some point, you were going to need the performance and the reliability of C++.
Indeed, there will be a lot of people who will pick up breakouts and actually prototype real products with the Pico. So they'll buy 100 Picos, 100 breakouts, and do that.
You do robot stuff quite heavily, and you're going to hit the limits of CircuitPython and Micropython pretty quickly, I imagine.
Yeah. Anything where you're doing high update loops, where you're doing lots of math calculations, will quickly blow through your performance. So I've kind of got into the habit of preferring C on that grounds, even if it's not necessary for every project.
Yep. And would there be any way to have those kind of performant things in Micropython, in CircuitPython? Do they have to be baked into the core to kind of access the C performant routines?
Yes, really.
I know this is a more complex question than it seems.
Yeah, you kind of need, because of the way we're doing the Micropython and it's going down to that level, we can do something really complex in short time and then come back. Because CircuitPython is always at that level, even for like simple read and writes, it will always add a delay. And you can compile the Micropython, which gives you a bit of extra performance, but not to the same level.
Yeah.
So all the libraries they provide are in pre-compiled state in their community bundle, and that helps a bit.
Yeah, but that's still bytecode Python rather than anything kind of super tight, right?
Yes, it is.
Yeah. And I think Andreas Space, I'm assuming I've got his surname right, did a good video showing kind of the maximum performance you could get from, say, a CircuitPython or Micropython loop. And I think it was reading the analog ADCs and getting about 7 kilohertz performance, which is not bad for playing around, but for things like encoders on motors, you're going to be lost. Right?
Yeah. That would give you one motor. If you're doing anything with wheels, you need at least 2 motors.
And as long as your Python isn't doing anything else. So there's kind of where the line. So let's switch over to CircuitPython now. Chris, you've been heading up the stuff where we've pushed our board definitions to Adafruit, to CircuitPython. Tell us about the whole process there and what's been going on.
Yeah, so that actually turned out to be relatively straightforward. Admittedly, I had Scott from Adafruit helping a lot, just pointing me in the right direction. But it was basically a case of following the guides, creating a fork of their repos, and then there's like 4 files that need to be defined. That just like say, here's the pins that are available, here's the amount of flash, and that's pretty much the name of the product. That's it. The only interesting point is having to define a custom USB PID, which you can get in various ways, but that should be unique for every product. So you can't just copy and paste from another product. Well, you can for testing, but you shouldn't if you're going to release something.
Not for production,
Exactly. So just so that the operating system as such can identify it uniquely from every other CircuitPython device you plug in. But yeah, they're pretty straightforward to set up, and then you just like commit that as a PR to their or pull request to their repo, and then update their the CircuitPython website with the links, and it automatically finds the correct folder to get the files from.
Yeah, because they've got this huge integration thing going on, haven't they? Which Phil might be able to tell us more what's going on there. But at the end of it, it's kind of like, hey, you've submitted your board to CircuitPython. Here's a page with the downloads for it in 12 languages, including Pirate and all of that stuff.
I don't purport to even begin to understand all that. There's so much workflow and continuous integration and continuous testing happening there. It's dizzying. When you raise a pull request, you just go.
It's like 200 checks it goes through because it's testing every board that they've ever added. Just to see you haven't broken anything.
They do regular builds up to the latest commit as well, but they've blown the limit on GitHub's uploadable binaries, I think. So they now have an S3 bucket or whatever where you can just go and get the very latest version of Micropython built against the latest commit. It's just
I think we got a new main release out the other day, which includes our boards in. So you can just go to get the main one rather than the very latest now for. That's the tiny 2040, the Kibo 2040, and the Pico system. So even though those last 2 aren't released, they're already defined.
Yep. And it means we're doing things like contributing a little bit to the drivers for things like the ISFL LED drivers, which is another aspect of it to make our stuff work.
It's not unprecedented because we had some effort around the Featherwing that we produced.
Yeah,
we
that's
got like the first toe dip into CircuitPython, but we're getting there.
Yeah, because basically Adafruit have been really good. They've been kind of holding cookies out to us, saying, "Come on, come to CircuitPython" for years.
And we've been kind of like, we don't want CircuitPython to not be just an Adafruit thing. I think they want it to be an everyone thing, and they're very welcoming and very supportive of anyone who wants to help them make that happen. I think.
Yeah, the community is there because they built it and encouraged it and put all this effort, time, money, whatever, right?
Mm-hmm.
Indeed,
yeah. Cool. So we've got to support that as well. I think we've got proper wheels on it now. The kind of EnviroFeather was a bit of a baptism of fire for us, wasn't it?
Oh yeah, still ongoing, in fact.
Yeah, and I think this is the other thing where the Micropython and the CircuitPython approach kind of makes sense to support both, because with that Enviro Plus, we ran into problems where with certain Feather host boards, the UART on the particulate matter conflicted with things like where that's being used for an ESP32 Hussar.
Yeah,
so tell us more about that, Phil. Yeah. It's kind of simple, right? There's only so many UARTs.
But basically, once you're developing a Featherwing, you're developing across a range of platforms that vary in their complexity, their ability, and what pins they use for what. So it's quite easy to footgun yourself and end up relying on some pins that might not necessarily be available on some platforms. And I think we ran into that and accidentally excluded ourselves from supporting certain things. I think that's where having a fresh start with Pico and directly connecting stuff to Pico is interesting. But I think due to the way that RP2040 is available to be integrated in all sorts of different form factors, we're just going to end up in a similar space, I suppose, where a lot of things have to be mindful of compatibility.
Yep. And this is where both Arduino and CircuitPython have a broad church in terms of platform support, right?
They really do. I very much like the niche down approach. I like a board that you have one form factor of, one way of programming it and one thing to do, because it brings out some really compelling and really interesting challenges, and people do cool stuff with it. People see limitations and they turn them into benefits. And this is something that we've seen with 32-bit, if I were to diverge momentarily into that, where we've created one platform, one way of doing things, and people have pushed it to the absolute limits. And I think we're seeing that again with Pico now as well, where it has the PIOs, it has the C++ way of doing things, and it has a relatively standardized form factor for the time being. And we're seeing people do really cool stuff with that. And indeed, we are ourselves doing some really cool stuff with that. And I think there's a lot still left to see while we're kind of in those formulative stages. And eventually those pushing the limits will just become the foundations of products based around the Pico, presumably.
Yeah. So as with the Raspberry Pi on small board computers, the Pico is a good rallying point for microcontrollers in their very basic
Indeed,
form.
yeah. When the Pi first came out, we had that very similar thing where lots of new ground was being laid, lots of interesting things were being done, and then eventually it just flattened out and just became this platform upon which people could do anything, really.
Yep.
That's
cool. So let's go on and give some love to the community. What's been happening there? Because obviously, day one, we released a lot of add-ons with kind of fairly unusual kind of basic, here's stuff that kind of works, but there was so much going on, and we're a relatively small team. So Pimoroni is about 37, maybe 38 people now, and that's across kind of manufacturing, admin, engineering, production, packaging, kitting, shipping, content, all of it. And when you split that down, that means that software-wise,
you're looking at them.
Yeah.
Not as many people as you might think. So it does mean that day one, we weren't where we normally are with, say, a hat release.
It doesn't help. So current circumstances have not helped the situation either. So just the lack of manpower and the general situation has made it very difficult to be where we'd like to be with this. And we have so many big ideas, just need more time.
Yeah, and I suppose as well, like, even though we knew about the product, the chip and the Pico before launch, that didn't give us a lot of time to get familiar with it enough to know what we had to do for most products, what the actual functions we needed for and stuff.
It kept changing.
Yeah, well, that's true.
Yeah, I mean that was 10, 12 release products on day one. Over a 3-month development cycle, it was insane amount of graft.
That was incredible.
Yeah.
But the flip side is there is this bunch of people, and if somebody looks at something they want to use and wants to use it in a particular way, they in some cases will just go out and write a driver and contribute it back before we're even that far down the to-do list, and that's happened in a few cases. Right.
In one notable case, I hadn't got past burning myself on one of our products when someone had written a driver for it already.
So which one was that?
Great. I think that was a 1.12-inch OLED I2C breakout. I had a really dodgy prototype one that was held together with 3M tape that had been in a box and been moved around, and it wasn't great. So I plugged it in and sort of left it, picked it up, and thought, well, this is a bit warm. Plugged it back in again, because that's the one thing you do when something's a bit warm, and then went to unplug it and touched the bit that was causing the warm and burnt myself. And then went, not touching that, ordered a new one. Before the new one had turned up, this guy, Simon3270 on GitHub, had pull requested a complete driver for it. So my first response was just like, wow, this is amazing. I hadn't got past burning myself on this. And you've already written a driver.
Yep.
Which is,
and unfinished stuff as well.
Indeed, with the tutorials and the documentation straight out of the gate, we weren't great with documentation because we've been spending so much of our time actually trying to get the devices off the ground that we hadn't even had time to think about how to tell people how to use them.
This is not great with documentation to Pimmeroni level, not to... Still, there wasn't anything there, but yeah.
But
and we've still got the...
we wanted to do it a bit better as well. So one of the things I was looking at earlier on was creating a separate website from GitHub that would be a bit more like your traditional like read the docs page for our products. That you could search and find specific functions and like just a bit more everything's here rather than have to go off to a specific GitHub repo. So we want to try and flesh that out in the future as well.
I think you were hamstrung by John being very, very busy with building things.
I got like a template working, and it was kind of really needed the input to be able to take it where we want to go.
Yep. But I think we're catching up, and we've got the schematics just about ready to release at some point, and the mechanical diagrams, because it's far overdue time that we started doing that as a matter of course, at the very least.
Yeah,
I mean, the pin-out diagrams pretty much straight after launch has been...
the pin-outs are very nice. Despite the lack of top-notch documentation, we have apparently attracted people from all backgrounds to the GitHub repository because we've got a lot of issues, a lot of pull requests. We've had people do everything from like a simple typo change to submitting a new example for something in C or Python to writing whole drivers, writing documentation. So we've hit the whole gamut. And I think the last time anything was this busy was the initial scroll fat, which somehow attracted a huge buzz on the GitHub repo. But the collation of Pico libraries and the popularity of the Pico has really brought a lot of people together doing stuff from all backgrounds, really. Yeah,
and hopefully we should have the kind of basic software done for Kibo 2040, so we can release that soon. We're still at least a month away from Pico system, I think, because there's a lot more engineering going on there with the actual product itself, let alone the software. But yeah, it's all coming together.
Yeah.
And it's only it's less than 2 months since launch, isn't it? Still.
It doesn't feel like it. It feels like an age.
But time's meaningless in this current age anyway.
It is.
It is. Yeah. Okay, that was a good catch up. And thanks very much for coming in and chatting about this. And let's do it again sometime.
It's been good.
We shall. It's been good
right.
times.
Take care, folks. I'll play us all out and see you soon.
Bye-bye.
Okay, so that was our first proto episode of Pirate Radio with Phil and Chris, who are head of software and software robots, Ingenue, Wonder Kid. I want to say thank you again to Pirates R Us for letting us use part of their KYAR Pirate Radio song for the theme tune. I'll play you out with that as well. Go check it out on Spotify and buy them a cup of grog if you bump into them anytime. And thank you very much for listening.